All right, everybody. I'm here where we left off with pH. A lot of you had questions on this. This was the last one. All I wanted was most bacterial species grow best at a pH of 6.5 to 7.5. It would have been fine if you told me around neutral, okay? Don't overthink these questions. You didn't have to give me specific temperatures either. You could have just told me really, really cold or really, really hot, okay? Don't get so boggled down with the actual numbers. I just want all these answers to be in your own words. They're all straight from the notes, maybe some from the book, but mostly the notes. That's what I just went over, and I'm gonna make my test, my quiz, my little review questions right after this. Also, I loved your feedback. Thank you so much. I'm really hoping that I'm making this as easy as possible for you because it's not easy for me because I have to redo everything that I've ever done, but I want to make sure that I'm doing it the best way and the easiest way for you guys because this is hard for everybody. All right, so this is talking about bacteria and where bacteria grows. So the next slide would be 33. So this one right here just tells you, it's just showing you exactly what we said. This is the temperature right here, and this is the growth rate. So psychrophills grow the best in the really cold temperatures. Mesophils, which are humans, I meant for that question to say we're mesophils, not mammals, but I still took it if you said mammals or animals. Um, this one right here is right at room temperature and a little higher. And then you got your thermophils, which are really, really hot. And then you have your hyper thermophils. So this just shows you what we just talked about that. All right, the next one is archaea. These are not like other bacteria in many ways, okay? The main difference is the makeup of their cell walls, their membrane lipids, their genetics, and their metabolism, okay? So archaea and bacteria are not the same thing. They're in a different domain. They're even in a different kingdom. So they're not the same, but they're similar, okay? The thing that they have in common was this slide right here. This one, plasmid, flagellum, and pili. And then the question about the where was it? Prokaryotes. This is kind of what I wanted with prokaryotes, but whatever you gave me, I took. Okay, I'm trying to be flexible. Just don't stress. Gosh. Okay, so here's the archaea. They're like bacteria in many ways. The makeup of their cell walls, the membrane lipids, and their genetics and their metabolism. Okay, these are not like bacteria in these ways. So these are different from archaea and bacteria. Sorry, I just said that wrong. All right. Archaea cell walls do not contain peptidoglycans. Remember, we talked about gram positive and gram negative. Gram positive has a lot of peptidoglycan, which every one of you got that right. Gram negative has peptidoglycan, but just not a ton. Archaeal cell walls have no peptidoglycan. Okay, so this is a protein carbohydrate, which means protein and sugar compound found in bacteria walls. It's not in archaeal cell walls. Okay, so that's one way they're different. Archaea genomes contain introns like eukaryote genomes. Remember exons and introns? With most things, we take out the introns, but archaea genomes contain the introns. We normally take those out and we just have exons, but these keep the introns. Okay. Archaea was first discovered in extreme environments such as swamps, which don't really have oxygen, salt lakes, which are really high salinity, and then hot springs, which is a high temperature. They also have been found on the surface samples from the North Pacific and Antarctic oceans. Okay, so cold, hot, salty, no oxygen. All right. All right, the next one is methanogens. Methanogens convert hydrogen and carbon dioxide gas into methane. Methane is a natural gas and it is a fossil fuel. Okay, so methanogens make methane. Oxygen is most poisonous to them as they can only live in anaerobic environments. Anaerobic means no oxygen. Okay, so this would be in very, very deep fresh water, marine mud, swamp mud, and sewage. Okay, when you smell sewage, that's like kind of that's got methane in it. Okay, and then you also know that methane comes from cow farts. So methane that bubbles out of sites such as swamps is called marsh gas. You always see that on the Scooby Doo episodes. They always have the green gas coming out of the swamps. That's really a thing. It's called marsh gas. Methanogens thrive in the intestines of cows and termites. So cows can expel between 200 and 400 liters of a methane a day. That either can be belching or farting. Okay, so they're really good company. So methane is an archaeal bacteria. Methanogens. All right, halophiles are salt-loving. Okay, they're called halophiles because they're made from halogens, which is group 17, like chlorine, bromine, all of those. So these are salt-loving halophiles. Halo comes from halogen. Phile means from love, like water, hydrophilic, hydrophobic. These are archaea that live in environments that have a very high salt concentration, kind of like Great Salt Lake. Okay. Thermoacidophiles. Thermo means hot. Acid means acidic. So these live in very acidic environments that have very hot temperatures. Okay. Some live in temperatures up to 110 degrees Celsius. That's above boiling. And then some live in a pH of less than 2. So very acidic, very hot. Thermoacidophiles. These are archaea. These are extremophiles. All right. Thermoacidophiles also live near volcanic vents or near hypothermic vents. Hypothermal means really cold. Hypo, below. Thermal, below. So that's temperature, so really cold temperatures. These prokaryotes are the primary source of food for the communities that live at the depths of the ocean floor. Okay. Oops. Same one. All right. No, did that one. All right. So this one right here, methanogens are hydrocarbon bacteria that make methane. Halophil means that they are salt-loving bacteria. They do not die in the salt. And this is why you'll see, like, when you're preserving food, like pickles and okra and stuff, they put it in a really salty brine solution so that bacteria does not grow. And then a thermoacidophiles means very hot, acidic, loving bacteria. All right, bacteria and archaea are structurally similar but have different molecular characteristics. Bacteria are commonly found in 3 forms. You have your rod-shaped, which are bacilli. You have your spherical, called cocci. And you have your spiral, which is called spirilla or spirochetes. Make sure that you know these 3. I'm going to definitely ask this on the quizzes or the review questions, and then I'm also going to put this on the test. Now, these pictures are wrong. This is rod-shaped. Okay, so lactobacilla, this is the stuff in yogurt. This is a spiral, but this label here is actually this one, and this spherical enteri, like E. coli, is actually over here. So this is E. coli, and then this is a spirochete. Okay, so bacteria, 3 forms: bacilli, rods, cocci, spherical, circular, balls. Okay, these blue balls, right? And then you have your spirochetes, which are spiral. Bye, y'all.